Alright guys, I'm going to give this a shot. It might be a little loud, I'm in a coffee shop. But if you're trying to find the integral of big fractions like this, there's a couple different things that you can do in order to find the integral. One of them is simplifying the fraction with division. Another is use substitution, which you guys know is the reverse chain rule. And finally we have the inverse trig function. Sometimes the inverse trig functions are really obvious. Sometimes they're not so obvious. And if they're not obvious, it's because you probably have to complete the square on the bottom to make it obvious. Just a quick review, completing a square looks like this. When you ever have like a trinomial like this, 3-term polynomial, and it's not a perfect square, you can complete the square by adding a blank and taking away the blank. So here I'm adding the blank, then I'm taking away the blank. And what you do is you take the 6 and you divide it by 2 and you square it, and you get the number that'll complete the square. Now I can complete the square, this part right here, to factor down to x plus 2 squared. And then of course you have your negative 29, because you also have to take away the 9. If you add it, then you have to take it away so that it stays the same thing. And right here is the key. This guy squared. This is what you're trying to do when you complete the square. And then when you look at remember your inverse trig functions for integrals, you can see why we need a perfect square. So the x here, a is a constant, x is your variable. If the variable is a perfect square, then most likely there's a good chance you're going to be using an inverse trig function, especially or only if it looks exactly like this. Now because there's a square root right here, that should tip you off that this is probably going to be an inverse sine function. So let's attack this guy. So I'm going to write it out on the bottom, and one thing you'll notice really quick is that what I do is I take out the negative. You can't complete the square of any polynomial if there is a positive 1 right here, or anything besides a positive 1. So I take the negative out. Don't forget to take out the negative from the other terms. That's a common mistake. And then you complete the square. So when I complete the square right here, I'm going to add 25 and take away 25. I'm not going to ignore this negative. Well, right now I'm going to ignore this negative just so I can complete the square. And then this guy right here is going to be the perfect square. And when I factor him out, he is x minus 5 squared. Then you have your minus 36. Now let's write it all together and clean it up. Okay, so now I rewrote what was inside right here, this. Next I'm going to distribute this negative out. When I do that, this is what I get. The 36 is now a positive 36, and I wrote him first just because normally we write the term that's negative on the other, like, second, not first. And then now you can probably see the a squared, the x squared, the square root right here. Here's your a squared, so that means a is going to be 6, and then here's your x squared. That means your x is going to be x minus 5. Now, you might notice that x minus 5 can be taken out, and you can use substitution to do that. But because when you do use substitution and then you find your du and it's just 1, then that means you don't have to worry about the function inside the function here. If our result had an x on it, like it said x dx right here, then you'd probably want to use substitution to make sure you guys don't make a mistake. But because it's just a 1, we can ignore the fact that it says minus 5 right here and just look at the x minus 5 as if it's an x. So after you notice it, you can go straight to your answer, because you can see that this is sine, inverse sine. You throw the x term up top, the a on the bottom, and don't forget your plus c.